This is the video on Module 3, Reducing Fractions. In order to reduce fractions, we need to first understand greatest common factors. So we're going to go back to something we've learned about factors, so I'm going to start by making my t-chart for the number 12. And I always start with my number 1, and I ask myself 1 times what would be 12? And it's 12. Then I ask myself, can I do 2 times something? And I know I can, so I would do the 2, and it's 2 times 6 is 12. Then I ask myself, can I do 3 times something? And the answer in this case is yes, I can do 3 times 4 is 12. Since I already have the 4 on here, and the next number would be 4, I'm done because I've already done it. So now I'm going to do the same thing for 18. And I'm going to go through and say 1 times what is 18? And the answer is 18. Can I do 2 times something? And yes, I can do 2 times something. So 2 times 9 is 18. Can I do 3 times something? Yes, I can do 3 times something. 3 times 6 is 18. 4 times something? Well, I can't multiply 4 times anything to make 18. And now I go to 5. I can't multiply 5 times anything to make 18. But I can do 6, but 6 is already there, so it tells me I'm done and I found all my factors. So now I want to find the greatest number on both lists. And it's common, so it's on both lists. And the greatest number in this case on both lists is the 6. So my GCF, or my greatest common factor, is 6. So some of you might be wondering, well, why are we doing this? We're doing this because sometimes you'll have a fraction that looks like this. And in order to reduce it, I have to divide the same number by the top and the bottom to make it smaller in order to simplify. So I want to find the GCF, and in this case it's 6, which we just did. And when I do that, I end up with 2/3, and that is how I simplify or reduce my fraction. So now we're going to go over here, and we're going to try the same thing with 8 and 16. And we have our 8, and we start with 1. 1 times what is 8? 1 times 8 is 8. Can I do 2? Yes, I can. I can do 2. 3 I can't do, and 4 is already there, so it tells me now that I'm done. So now I'm going to look at 16, and I know 1 times 16 is 16. I can do 2. 2 times 8 is 16. 3 I can't do. 4 I can. And once I have a number that shows up on both sides, I know I'm done. So now I look at it, and I look at what's the largest number on both lists, and it's 18. So in this case, sorry, it's 8. When I have 8 over 16 as a fraction, if I divide that by the GCF of 8 over 8, then I will get 1 over 2, which is 1/2. So we have 10 and 30. And we're going to make our lists again, but before we make our lists, I'm going to just write the fraction here. When I look at this, some of you might think that the GCF of this is 5. So if you went to do this without doing the workout, you might do this, and you would end up, I apologize, not 6, you would end up with 2/6. When I look at that, they're both even numbers, and because they're both even, I know I can simplify or reduce even farther to get it to lowest terms. So in this case, I then would have to maybe divide them both by 2. And I'd end up with 1/3. Now, however, though, I'm going to look up here, and I'm going to make my t-chart. 1 times 10, 2 times 5, 3 doesn't go in, 4 doesn't go in, and the 5's already there. So now I'm going to do my 30. 1 times 30, 2 goes in 15 times, 3 goes in 10 times, 4 doesn't go in, 5 does go in, 5 times 6, and 6 is already there, so we're done. And I see that 10 is the largest, it's the GCF. So now I'm going to take my numbers that I had on the bottom, and I'm going to do it again, but this time I'm going to do it using my GCF. And I end up with 1/3, which is the same answer, with just a lot less work because I only had to divide once. Another question you can ask yourself is, can this number go into this number? And if it can, then right away I know that's the GCF. So I'm going to come over here to 6 and 15, and I see that I have 6 and 15. I'm going to ask myself, can 6 go into 15 evenly? It can't, so that's not the GCF. So then let's go and make our t-chart. 1 times 6, 2 times 3, and we're done. And then we'll make our t-chart for 15, and we have 1 and 15. 2, it does not work. 3 and 5 works. Nothing for 4, and 5 is already there. So the GCF is 3. So we're going to take our 6/15ths, and we're going to divide the numerator and the denominator by the same number, and we're going to end up with 2/5 as our reduced, simplified lowest fraction. So now I've shown you the process as we go through, and I'm going to show you now when you don't write the whole chart out. So I can look at this. I have 14 and 21. 14 does not go into 21 evenly, but I know looking at this that 7 can. And I end up with 2/3. No number can go into 2 and 3 besides 1, so I know I'm in my smallest terms and I simplified and reduced to the smallest I can. Next we have 3/9. 3 can go into 9, so I know that 3 is the GCF. And I end up with 1/3. 4/8. 4 can go into 8, so I know I can divide to reduce to simplify. And I end up with 1/2. So when we want to make an equivalent fraction, we can always multiply and we can always divide the numerator and the denominator by the same number. So we just did these three. So now we're going to look at 10/40ths. Well, 10 can go into 40. So right away I'm going to divide by 10 and I end up with 1/4. So now I look at the next one and I have 8 and 64. So 8 can go into 64, so I'm going to divide them both by 8. But now when I get to 40 over 64, I don't know the greatest common factor. So over here, I'm just going to find my GCF. So I can do 1 times 40, 2 times 20, 3 does not go in there, 4 does, 5 does, 6 does not, 7 does not, 8's already there. So now I'm going to look over here. I have 1 and 64, 2 and 32, 3 does not go in evenly, 4 and 16 do, 5 does not go in evenly, 6 does not go in evenly, 7 does not go in evenly, but 8 does, and now I'm done. So now I'm going to look at these, and I see that my GCF for these two is 8. So I'm going to divide both of these by 8. And I end up with 5/8. And now I've simplified, reduced, or put in lowest terms. So here we have 50/60ths. 50/60ths, I see that 50 cannot go into 60. But when I look at those two numbers, I think 10 can go into both of them. So we're going to try that. And I end up with 5/6, and that is the smallest that I can go. So then I have 18/27ths. I'm going to look at them. I know 2 can go into 18, but not into 27. I know 3 goes into both of them. I'm going to keep going and see if anything else can go into both of them. 4 doesn't go into both of them. 5 doesn't go into both of them. 6 doesn't go into both of them. 7 does not go into both of them. 8 does not go into both of them. Oh wait, 9 goes into both of them. So I'm going to try 9. And I end up with 2/3. But if for some reason I didn't see that, and I thought that 3 was the biggest one, we're going to try it and see what would happen. And we would end up with 6/9. And when I see 6/9, I would have to say to myself, you know what? 3 can go into both of those. And I'd end up with 2/3. Same way, just more work. So now I'm going to look at this last one. 3 can go into 24, so right away I know I can divide by 3. And I end up with 1/8. 8 and 12, well, I can divide them both by 4. And I end up with 2/3. 30/80ths. Whenever I see numbers this large, I tend to divide them by 10. And then 8/48, I notice with this one that 8 can go into 48, so I divide it by 8. So now I'm at 40/48, and I don't see 40 going into 48. But when I look at these two, I see that 8 can go into both of them. From knowing my facts, I can see the numbers easily. When I have 16/24ths, I look at this, and I notice that 8 can go into both of these. And when I see 24/32, I once again see 8 as another one of these. And that's how we simplify, reduce, or put numbers in lowest terms.